Now, unlike DNA replication with the replication bubble, we see here that the bubble for transcription never actually gets bigger. Once RNA, polymerase initiates transcription by pulling apart the two strands, I mean, that bubble is only like 10 to 20 nucleotides. And that's it. It's not going to get any bigger. RNA polymerase will then just start moving down the double helix. Pulls apart new nucleotides in one direction, allowing the nucleotides to come back together in the other direction. So it's a moving bubble that does not get any bigger, any smaller. And it moves rather quickly, 40 nucleotides per second. Turns out the hardest part is initiating this. Once RNA polymerase gets started, it just goes. And it will continue to keep going through the gene. It unwinds in front in the direction it's moving and allows the double helix to rewind behind it. So this transcription bubble, as I said, never gets bigger, never gets smaller. The termination signals, the termination events are going to be different, whether you're talking prokaryotes or eukaryotes. In prokaryotes, there is actually a region of DNA at the end of genes or at the end of what they call operons, sets of genes. When the RNA polymerase hits this region, it becomes unstable and it just falls off. Different here in us eukaryotes. In us eukaryotes, RNA polymerase transcribes only one gene. There are no operons in eukaryotes. RNA polymerase hits the end and goes just a little bit further. Adds in a little bit more just as a spacer, and then it does this really neat thing. It just starts adding on A's. How many A's? Dozens, hundreds. As we're going to see in a later mini lecture, that's the poly A tail. That poly A tail that can be dozens, hundreds, 2, 3, 400 A's in length is a buffer so that as the messenger RNA starts to degrade because enzymes are chewing it up, has to go through all those nucleotides first, that poly A tail, before it actually gets to the gene that's being translated.